In the previous video, we created a bronze model. Now it is time to convert this bronze model into silver models. Now we will be creating total 3 silver models. However, in this particular video, we will be focusing on 2, which is the clean silver model and the quarantine silver model. I will be explaining the differences between these two models in the video itself. If you're new here, then I am Radhika and this is my YouTube channel datasets. We are continuing our DBT series, and if you have not subscribed to my channel and want to learn more, then please do subscribe. If you like the content here, then I would encourage you to like the video and share your feedback in the comments below. And now without further ado, let's get started. Before doing anything, let us push our code into GitHub. So for this, I'm going into my GitHub repository folder, and in here I'm going to do git status. And we know that we have changed these files because we have deleted the demo file and have updated the dbt_project.yaml file, and we have to add this bronze folder as well to git. So let's add that to staging area in GitHub. Then let's check the status, and now we're going to commit this code. So I'm going to write message bronze model created, and now let's do git push origin main so that this goes into GitHub. Now that we have committed our code into GitHub, let's start working on the silver layer. Now I want to give you an idea of what we are essentially doing in silver layer so that it becomes easier for you to follow the video ahead. So in this silver layer, the idea is we are going to add lookup data to our bronze data. So here is our bronze layer or bronze model. To this we are going to add lookup data, and then we are going to split this into 2 models, either a clean model or a quarantine model. Now first understand what is this lookup data thing. So if we go to our bronze model and let's just run this. So when you run the bronze model, you can see that there are columns like education 1, 2, 3, 4. Somebody's education can't be 1, 2, 3, 4. There is meaning attached to it. So I have this CSV file where I have meaning related to education. So it says when education level is 1, if somebody is indicated that their education level is 1, it's just tertiary qualification. If it is 2, then it is diploma. 3 means bachelor degree, 4 means master's degree, and 5 means PhD degree. So these are the numbers indicating what is their education value. Similarly, there is another column which is called as job involvement. So you look over here, there is data 1, 2, 3, 4. Employees are rated for their job involvement depending on the scale 1 to 4. Now this scale has a meaning to it. That meaning for us is stored in this CSV file again. So if you look here, 1 means below expectations and 5 means goes above and beyond, and then there are values in between. So it is a range, and each range indicates something. We have to get this information into our silver model because these are the lookup values that we need to add. When we are building dashboards, then if we say somebody's job involvement is 1 or 2, or they have to provide information about the education qualifications of our employees and we say it is 1 or 4 or 5, it doesn't make sense to the stakeholders. What they want to see is how many people have tertiary qualification, how many people have master's degree, let's say. So we have to add this data into our silver layer, which means we have to add these lookup values. These 1, 2, 3, 4, 5, they are lookup values. So this is exactly what we are going to be doing over here. And to do this, we just have to join our bronze data with this data. How we will be doing it, we will see that at a later stage, but let's understand the idea. So we will have to join the tables. That's one thing. Now what is clean and quarantine data? Now there are 2 concepts, clean and quarantine. I will explain our use case first. We have a created add date, and we are saying that this created add date is very crucial for us. So we don't want this to be null at any time in our data sets for us to perform analysis on the data. So If ever our created at date is null, like this column is null, then we want to send this to quarantine dataset or quarantine model. And if it is not null, then we want to send this to clean data, because then I want to perform analysis on top of this data. So this is what the scenario I'm trying to mimic over here. So if we are finding our created at is null, we're sending it to quarantine. If it is not null, we are sending it to clean. Now, we don't just have to stick to one column. Suppose that there is a column called as departments. Suppose that there were departments A, B and C. Now suddenly you are getting department D, but you don't have this in your DBT project that D is a valid department. So what you can do is, for the rows that are coming with D department, you can put them in the quarantine data set or quarantine model, so that you can talk to the source system and understand, is this a new department, a legit department, or what needs to be done for this particular department. And then once you know how to handle this data, you handle it and then push the data to the clean department, to the clean model. So this is how clean and quarantine are working. This is very common scenario in your day-to-day as a data engineer. So I wanted to show you how you can achieve this in DBT as well. So this is all what we are going to do for now in the silver layer. And after this, we are going to have our enriched layer where we are adding flags and buckets and whatever we have discussed earlier. But let's just try to do this much for now. Now, while I'm explaining this silver layer and while we will be doing all of these things, we will be working with DBT seeds. And also I will be showing you ref keyword. So these are the two things that we will be understanding in this particular video, which are new. So now let us start building our silver model. For our silver layer, I'm going to be creating a file in our silver folder, and I will call this file silver_hr_data, because what this data is about. And then I'm going to write clean, because this is my clean model, with lookup values. Be as descriptive as you can, because then the model names make sense and you know what is happening in each of these models. And I'm going to end this with .sql extension, because we are creating an SQL model. Now in this we have to write CT. So I'm going to start as with base as. Now this is my base query, and for this query all I'm doing is I'm getting data from bronze model. So I will write the column names later on, but let's understand how we can bring in bronze model here. So now in DBT, we don't just write model name as is to reference one model into another, because we have to reference bronze model into the silver one. We have to use ref keyword. Ref means we are referencing the model. So the ref keyword works like, you have to put two curly braces, because this is Jinja template, and then we have to write ref and whatever model name we want to refer. So for us it is bronze HR data. This is the model we want to refer. By this we are saying that we are referencing this bronze model. So you can see DBT is making things really easy for us, and when you are using these ref keywords, you are also building the data lineage or the lineage graph, which we will be seeing later on. So now we have to provide the column names that we are bringing in. So I'm just going to copy the column names here. It is always best practice to write column names rather than saying select star from here. That's because what if your schema has changed? You will not be aware of that schema and you might be bringing some columns that you don't need. So you should always write the column names that you want to bring into each of these models. So I'm adding the column names here, and the only difference is this last part, where for created at date, I am updating this date format to be DDMMYYYY. So to do that in Snowflake, we have to write try to date, which means try to convert this to this particular date format. And we are giving the column name that we have to give and the format that we have to convert this into. So this is the only difference that I am doing right now. This forms our bronze data. Now, like I said, we have to add the lookup data to it. So here we just have education, which is this column 1 2 3 4. We have to provide data related to 2. What does 2 mean? That is diploma. So to do that, like I said, we have to do joins. So I'm going to create another query here. So another CTE, I'm going to call this as final. And in this final, we are going to say select. We're going to write the columns later on. But for now, let us add from base B. Now this is just your simple join statements, and I'm sure you know SQL, so this will be easy for you. So we're going to do a left join. Why left join? Because what if the scores that we are giving 1 2 3 4, later on you're getting a 5? We don't want to lose that data. We want to still keep that data and understand what can be done with that data, but at least we are grabbing that data. So we want to keep a left join so that we have all the rows from this base table. And then we have to now get the data from those CSV files. But now you would be thinking, we don't have those CSV files in our DBT project. So how are we going to use that? This is where the concept of DBT seeds come into picture. So what are DBT seeds? DBT seeds are these static and small data sets that are in the form of CSV files. So what we do with these is we put them into DBT in seeds folder. There is a folder called as seeds in DBT. We put it there, and when we run these seeds, then we get these CSV files converted into table in Snowflake. So instead of putting these files directly into Snowflake, this is the easiest way that we can do. We just push these CSV files into our DBT project in this folder, and when you will run the command dbt seed, that's when DBT is going to convert these CSV files from your DBT into Snowflake table in Snowflake. So let's see this in action. So what I'm going to do is I'm going to be adding those files over here. So I have got all those files, and remember that you have to put them in the seeds folder, because that's only when DBT is going to recognize these are seed files, and ensure these are small files. The only functionality for these files is to do the lookup. We don't want to transform any data, because then you should be adding these as models or as sources, but not as seed files. So I'm just bringing those files over here and putting them in seeds. I have added all those CSV files. There are 8 columns if you look into our data set which need this lookup, and you would see that there are these 8 files that we have added here. Now we have just added the CSV file, but like I said, we need to run this dbt seeds command so that DBT recognizes these as tables, and then we can do the join with our models on these tables. So in our terminal, what we will do is we will first go to our DBT folder. I am in DBT folder, so now I will just do DBT seed. Now as soon as I run this DBT seed, you will see that DBT is converting these and sending these as tables. So you can see here loaded seed file staging.education_lookup. Let's go to our Snowflake and refresh, and you can see that these files, education lookup, environment satisfaction lookup, these are the lookup CSV files that we added in the DBT seeds folder. Now you can see them as tables and you can query it too. So let's query one of these tables. So I'm going to write select star from HR_analytics dot staging. That is the schema where these are syncing in. And remember, we can change the schema as well if we don't want this to go into staging, and we will be doing that later on. And then let's look at education lookup. So if I run this, you can see that we have 1 2 3 4, and the same data that we had in our CSV file is now in Snowflake. So you see how easy it is to convert those CSV files into tables. So now that we have these files ready, what we can do is in our silver layer, I can write the join condition. And like the way we were using ref keyword to reference other data models in our other models in our current model, we are again going to use ref keyword to refer to these or reference to these seed files as well. So I'm going to say ref, and first I will join with education lookup. So I'm calling this EL, and then we have to write join condition. So I'm gonna say b.education because that is what the column is. Let's go to bronze and just run this so I can show you. So we write b.education because this is the column where we need to add write the join condition equal to EL dot. Let's go to education lookup, and here the column name is education level. Whatever column name you define in the CSV file will be the column name in your table as well. So that's why I'm writing education level. So similarly, you have to write these left join conditions for the rest of the tables as well, or the seed files as well. So I'm just going to copy what I have so that I don't have to waste time over here writing this. So now I'm I have written all of these conditions. I'm joining with job involvement lookup, then job level lookup, job satisfaction lookup, performance rating lookup, relation satisfaction lookup, work-life balance lookup, and environment satisfaction lookup. I am joining with all these tables, and now let us get the column names. So as you can imagine, we need all these columns from the base table because we need all of these. We don't want to remove this information just yet, but we also need to get these values of these lookup columns. So to do that, let me just grab the column names and let's put that over here. So I'll explain you, just let me format this. So as you can see here, we have got most of the columns from this base query, but there are columns like education value. This education value is this column that we want. Similarly, we have environment satisfaction value. So if we go to environment satisfaction, this is what we are getting as a column in our table. So let's just run this, so it will make things more clear for you. So I'm going to say select star from, and we have to write our final CTE name. So I'm referencing it like that. Let's save it, and now let us run this. So now when you run, let's move to our education column, and you can see we are getting this education value. 2 is diploma, 1 is tertiary qualification, 4 is master's degree, so we are getting this information. Similarly, for environment satisfaction, we had 2 as unsatisfied, 3 as satisfied, 4 as extremely satisfied. So we are getting data, and we have now formed an enriched data set for our silver layer. But there is a problem here. Like I was saying before, we have to split this into clean and quarantine, and our condition was this created at date. So let us write this condition. So I'm going to say that we only want this where our created at is not null, because this is clean column, and I'm just going to save this. So now let us just run this, and you can see that we have got the data now. There will be no row which has created at as null, because that's the condition that we are putting over here. Now in a similar way, we can send data to quarantine. The only difference is we have to change the condition here, and we have to add 2 more columns to the quarantine data set. A quarantine reason as to why we are quarantining it, and also the timestamp at which we have quarantined that data. So I'm going to copy this, and now let's create a new model. So I'm going to call this silver HR data. Now this is quarantine, so quarantine and with lookup values .sql. So now I have just copied clean model in the quarantine model because there are only minor changes required. Base query remains as is, we don't touch it. The only thing is, in our final CTE, we have to add a condition, add 2 more columns over here. So first is case when created at is null, then we have to write the reason. So we are writing invalid created at as the reason, and then end as quarantine reason. I'm calling this column as quarantine reason, and then I'm adding current timestamp as quarantine date. Quarantine date. So we have done this, and we have to change the condition that now created is null. That's when we want to sync data over here. Now when you will be running this column, you will not be getting any rows over here because all our data has currently has created date. We have got a problem here. Okay, we have to put this in single quotes. Now let's just run it again. And now you can see that we have got no rows because currently there is no row in our HR data, like staging.hr data in Snowflake, where we have created data as null. Now let us try to mimic a scenario where it is null. So for this, I'm going into my Snowflake query and I'm mimicking this scenario. I am adding an employee with employee number 100113 where the created date is null. Let's add it. Suppose this is how the data came. Now when you will add this, and now let us go to our quarantine model and run this query. Now that 10013 should come over here, as you can see, because it's created at is null, and because it is in the quarantine model, you can see that it has a quarantine reason column which is invalid created at, so that we know what is the problem and why we have quarantined it, and also the date at which we have quarantined it. So this makes it handy for data engineers now to go back to the source system team and ask them about what's happening, how to fix this, etc. Now let's say the data engineer went, talked with the team, and they said, yes, we found the problem and we are fixing it. And the way they have fixed it is they have added a created at date to this particular employee. So let's mimic that scenario. So what I'm going to do is I'm going to say in the staging.hr, whatever is for this particular person, like employee number, you put created at date as this date. Now let's just update the record. And now once this is done, let's go back to our quarantine data and again run this. Now you would see that this quarantine record is gone because we have fixed the issue and there are no created at rows which have created at as null. So now you see how easy it was to filter out the rows which were not adhering to what we wanted them to. So we send them to quarantine, and when the issue is fixed, they go back to clean data. Now to see that this has gone back to the clean data, let's just run this. So before running dbt run to build these models into Snowflake, I'm going to update the configuration in dbt_project.yaml, because for these silver models, I want to create a separate schema. I want this to go into silver schema, and I want these to be created as tables, not as views. So I have added these configurations in the dbt_project.yaml file. I hope you now understand why we are doing these things. And now let us just quickly run our models. So this will create a silver schema first, and then we'll add these two models in that silver schema. Now we have got a failure here. Compiled code add this. Oh, I have written tables. That's a typo. So now let's just quickly run this again. So dbt run. Now that it is fixed, you can see that our bronze model is created in the bronze schema and our silver models are getting created in the silver schema. To verify, let's go to our Snowflake, and currently you can see we just have bronze and staging. When I refresh, you will be able to see these silver schema and these two silver models created in that as tables. Now let us look into our silver schema clean model. So select star from HR analytics dot silver dot the clean model for silver. I just want to see that our employee number 100113 is existing here or not, so that we can be assured that it got transferred from our quarantine table into this table. So we can see that we have got this record and now it has got that created date. So that's why it has moved from quarantine to clean. Now we will build the third model of our silver layer in the next video. But in this video, as we have talked about dbt seeds, so let us see some configurations that you can do related to that. Now, as you may have guessed it already, that the config that we are going to define for seeds will be in dbt_project.yaml file. So let's do that. So like we have configuration for models, we can do the same thing for seeds. So I'm going to write seeds, and then we will have dbt_HR_analytics, because that is our project. And in here, the first thing that we are going to define is the schema. So I don't want my seed files to be going into the staging schema. I want it to go into its separate schema. So for this, what I'm going to do is I'm going to say plus schema, and I'm going to call this schema as seeds. So I'm defining that this is where I want my seed files to go. Now in this place, we can also define the column data types of the columns that are there in the seed files. To do that, what we need to do is we first have to write the seed file name. So for us, I'm just going to define this first for education underscore lookup. Always ensure that this name is exactly as how is your CSV file's name, because these are case sensitive. Then we can define the columns. So we're going to say column underscore types, and then we have to provide the name of the columns. So the first name is education level. So I'm going to go into this dbt underscore project.yaml, and then I'm going to say education level. I want this to be an integer, so I'm going to say int, and then the next column is education value. So for this, I'm going to say education value as varchar, and I'm going to say this is of 25 characters length. In this way, we can define column types for all of these seed files. But the recommendation from DBT is that when DBT is going to convert these CSV files or these seed files into table in Snowflake, what DBT does is it tries to look at these files and tries to infer what is the best data type that DBT can assign to each of these columns. So DBT will look at a few rows and then decide the data type. So usually DBT does a good job at it, but if it has not done a good job and you want to specify a certain type of data type to a column, then only DBT recommends that you use these settings. Now, I don't want these settings because let's go back to our Snowflake. Let me just quickly log in. So here you can see that if I go over education lookup and I go to the definition, I can see that this DBT has assigned education level as a number, education value as a varchar. So it is able to detect that this is an int and this is a varchar. So I don't want to change these things. So I'm not going to add these over here, but I just wanted to show you that this is how you can define the data types according to you if you want to. Now, till now, I have not mentioned this, but you can define configurations at a few other places as well. So let us look at that in this particular video. So what I'm going to do is, I'm going to create a new file over here and I'm going to call this with underscore seeds underscore properties dot YML. So you can create these YML files where you can define configs related to seeds. Why are we defining these over here and why not to include these in dbt underscore project.yaml file? We are going to discuss all about this in a separate video, but understand that this is also what you can do. So in this particular file, the way to write it is similar to your sources.yaml file. So you were writing sources, but here you will write seeds, and then you have to give the name of your seed file. So our name is education underscore lookup. This is case sensitive, so ensure that you write it in the way it is written. Then we can give the description. For description, I am saying that this seed file contains education levels and their corresponding values. This is what I am writing. Then we can define the columns here, and in columns we can define what each column is. So I'm going to say name. Let me just grab this information and paste it so that I don't have to type it. So in here I'm defining education level. There are two columns in education underscore lookup, education level and education value. So I am saying that education level, this is unique identifier for the education levels. I have given this description of the column, and for education underscore value, I have given description. This is value corresponding to the education level, namely all of these. You can add as much as information you like to have it over here in your description. So I'm going to do this for all the other files as well. So let me just copy what I have written over here. So as you can see, I've done the same thing. This is the name of the seed model or seed file. You write the description of it first, then you define the columns, and similar to this pattern, you define the name and then description. And I have done this for all of the seed files that are present, and you can do the same. As I will be uploading this on GitHub, so you can get all of this information from my GitHub profile as well. So now I'm going to save this. There are a lot of other configurations that you can do in both of these places, like dbt_project.yaml file and this seeds_properties.yaml file. Please refer to the DBT documentation if you have a specific use case, and I'm sure there is a configuration provided by DBT for that. Now, the last question that I would like to address in this particular video is, what is the difference between these seed files and model files? So these seed files, they are just raw and static files, whereas our model files, they are for transforming the data using SQL. These seed files, they don't transform, they just load the data into your project. So if you just need to load data and use it, then use seed file, and it should be small and static. If you want to transform your data, then you should create a model. Now, after we have defined all of this, as we have added new configuration and previously we had already built our dbt seeds, so what we need to do is we need to run this command dbt seed hyphen full refresh. This is what we need to do so that it refreshes and takes on this particular config. Now it's going to rebuild all of these seed files. It is still taking staging schema, maybe because I have not saved these seed configs over here. So let's save it and then rerun this. So we need to do dbt seed hyphen full refresh. Now you see that our seeds are getting created in a seeds schema. Let's go into our Snowflake and verify this. So I'm just going to refresh, and we can see that the seeds schema is created and we have got seed tables over here. That's it for this particular video. Please let me know if you have any questions in the comments below. Thank you for watching. I will see you in my next one.